Everyone knows locomotives are supposed to stay on the rails. But in the early 1950s, Soviet engineers built a machine so powerful it did the opposite. It pulled the rails right out of the ground. The problem wasn't a design flaw. It wasn't operator error. It was pure, overwhelming force. The locomotive in question generated so much tractive effort that when its wheels gripped the steel rails and pulled, something had to give. And what gave wasn't the load behind it. It was the infrastructure itself. This is the story of the P-36, a Soviet passenger express locomotive that redefined what too much power actually meant. In 1950, Soviet railways faced a crisis of ambition. Stalin's government demanded faster passenger services across the vast Russian landscape. In the existing steam locomotives, reliable workhorses from the 1930s couldn't deliver the speed or pulling power needed for increasingly heavy passenger consists over long distances. Soviet engineers at the Kolomna works received a clear directive: build the most powerful passenger locomotive in the world. They succeeded, perhaps too well. The P-36 emerged from Kolomna in 1950 as a streamlined crimson-painted giant. Its specifications read like fantasy: a 4/8 wheel arrangement, 650 square meters of heating surface, boiler pressure at 15 kilograms per square centimeter, and, most critically, a starting tractive effort of 20,300 kilograms. For context, that's roughly 44,750 pounds of pulling force at standstill. Contemporary American passenger locomotives like the Southern Pacific GS4 generated around 38,000 pounds. The P-36 exceeded them significantly, but raw numbers don't capture what happened when that force met reality. The first trials took place on the Moscow-Leningrad main line in early 1951. Engineers loaded the P-36 with a 650-ton passenger consist, 14 coaches, fully loaded, standard procedure. The locomotive sat at the platform, steam pressure climbing, waiting for departure clearance. When the engineer opened the regulator, witnesses reported a sound unlike any departure they'd heard before. Not the clean chuff of wheels finding purchase, but a grinding, tearing screech of stressed metal. The P-36 moved, the train moved, but so did the rails. Inspectors found sections of track visibly displaced from their sleeper beds. The rails hadn't broken. They'd been yanked laterally, up pulling the spikes that held them to wooden ties partially out of the timber. In extreme cases, entire rail sections lifted slightly off the ballast before settling back down. The phenomenon occurred specifically during maximum effort starts from standstill, when the locomotive's enormous tractive effort concentrated on a relatively small contact patch between wheel and rail. Soviet engineers initially suspected track quality. The Moscow-Leningrad line, though a prestige route, still used some pre-war infrastructure. They moved testing to the Trans-Siberian Railway, where track maintenance standards were theoretically higher. The same problem occurred. On grades, where the P-36 had to work hardest, the rail displacement became severe enough that speed restrictions were briefly imposed. The physics were unforgiving. A tractive effort is force applied at the rail head. When a locomotive pulls, it's essentially trying to move the entire Earth backward while pushing itself forward. Newton's third law ensures the rail experiences equal and opposite force. Most locomotives generate manageable forces that the track's fastening system, spikes, plates, ballast, can easily resist. The P-36 exceeded those limits. The problem intensified because the P-36's driving wheels were 1,850 millimeters in diameter, relatively large for a passenger locomotive. Larger wheels mean better high-speed performance, but also greater leverage at the rail contact point. When combined with the locomotive's massive boiler pressure and precisely engineered valve gear, the result was a machine capable of applying forces the Russian railway infrastructure wasn't designed to withstand. The Soviet engineers faced an unusual dilemma. They'd built exactly what was requested, the most powerful passenger locomotive in their inventory, but that power created infrastructure damage that threatened operational safety. The solution couldn't be build a less powerful locomotive. That would be admitting failure. Instead, they had to reinforce the infrastructure to match the machine. Between 1951 and 1953, sections of the Moscow-Leningrad and key Trans-Siberian routes underwent intensive track upgrading. Heavier rails replaced lighter sections. Wooden sleepers gave way to concrete in high-stress areas. The ballast bed depth increased from 25 centimeters to 35 centimeters on grades. Fastening systems were redesigned with deeper spikes and additional clips. The Soviet railway system spent millions of rubles essentially rebuilding track to accommodate a single locomotive class. By 1954, the modifications worked. The P-36 could operate at full capacity without damaging rails. But the irony was inescapable. The locomotive forced the infrastructure to evolve, rather than being designed to work within existing limitations. In service, the P-36 proved magnificent. It hauled the Red Arrow Express between Moscow and Leningrad at unprecedented speeds, maintaining 120 kilometers per hour on level sections with 700-ton consists. Crews praised its smooth riding characteristics and responsive controls. Passengers never knew the technical drama that had preceded their comfortable journey. Between 1950 and 1956, Kolomna Works built 251 P-36 locomotives, making it one of the last mass-produced steam passenger classes in the Soviet Union. The P-36's power wasn't just marketing hyperbole. Documented tests from 1953 show the locomotive sustaining 3,000 indicated horsepower at 90 kilometers per hour, exceptional for a steam design. Its efficiency came from a combination of factors: high boiler pressure, large firebox volume allowing complete combustion, and sophisticated valve timing that maximized steam expansion. Soviet engineers had essentially pushed steam technology to its absolute limits, yet this achievement came with constraints. The P-36 could only operate on routes that had received the expensive track upgrades. Lighter branch lines remained off-limits. The locomotive's weight, 134 tons without tender, meant bridges required inspection before it could cross. Its appetite for coal and water matched its power output. Consumption rates reached 15 kilograms of coal per kilometer on heavy gradients. Operationally, the P-36 was spectacular but demanding. The rail-ripping phenomenon became railroad legend. Veteran engineers who worked with the P-36 recalled the distinctive sound of maximum effort starts, a metallic groan that signaled enormous forces at work. Some claimed they could feel the track shift beneath their feet when standing on platforms as the locomotive departed. These accounts, while likely exaggerated through decades of retelling, point to a genuine technical reality. The P-36 operated at the absolute edge of what steam traction could achieve within conventional railway infrastructure. By the late 1950s, dieselization was already transforming Soviet railways. The P-36, despite its impressive capabilities, represented the end of an era rather than the future. Diesel locomotives offered similar or better power with far lower maintenance costs and no infrastructure stress from extreme starting tractive effort. The last P-36 was built in 1956. By 1974, all had been withdrawn from regular service. Today, several P-36 locomotives survive in museums and as operational heritage locomotives. P-36-0251, the final production unit, occasionally hauls special trains on Russian railways. These preserved examples demonstrate the machine's elegant design, the streamlined casing, the massive driving wheels, the crimson paint that became synonymous with Soviet express passenger service. But they rarely show what made the P-36 truly remarkable: the sheer mechanical violence of its maximum effort performance. Knowing the 36 stands as proof that engineering excellence isn't always about pushing boundaries. Sometimes it's about recognizing where boundaries should be. The Soviet engineers who designed it succeeded brilliantly at their stated goal. They created a locomotive more powerful than any passenger steam design before it. But that success revealed an uncomfortable truth. Some machines are simply too powerful for the world they inhabit. The rails couldn't hold. The infrastructure had to change. And in changing, it proved that the real limit wasn't the locomotive's design. It was everything around it. In the end, history remembers the P-36, not for the records it set or the speeds it achieved, but for the impossible problem it created. What happens when you build a machine so capable that reality itself can't contain it? The answer, written in bent rails and displaced ballast across thousands of kilometers of Russian track, is that reality adapts or breaks, and sometimes, briefly, both.